Hello, my remarkable pre-calculus class. We are ready for another online adventure. Today, we're going to sketch one cycle of our cosecant function. This is our cosecant function. The cosecant function will have two pieces. You're going to have a part that's concave up and a part that's concave down. Again, two pieces for a cosecant function. We have our A, B, C, D again. We're graphing the y equals cosecant of x. Here I put in the a1, the b1. Since you don't see a c, it's 0. You don't see a d, it's also 0. We're going to be using our 5 steps again, our 5-step procedure for finding this one cycle. And we have to remember this also. Remember that cosecant, and sine are what reciprocals. So cosecant of x is equal to 1 divided by the sine of x. Remember, we can never have division by 0. So when we're sketching our cosecant curve, wherever the sine of x is equal to 0, we're going to have vertical asymptotes. Now, here, we're going to graph y equals cosecant of x. The very first thing we've got to do is graph its reciprocal first, which is sine of x. Here, the period this time is 2 pi divided by the absolute value of b. Just like for sine and cosine, period is 2 pi divided by the absolute value of b. The number of radians it takes to complete one cycle. Here is the inequality that we're going to use for the cosecant, just like we use the same inequality for sine and cosine. 0 less than or equal to bx minus c less than or equal to 2 pi. So we're going to start off, and the very first thing that we're going to do, we're going to graph y equals sine of x. So we can find out where our vertical asymptotes are. So we're going to use our 5-step procedure. Our bx minus c is x. We want to get x all by itself in the middle, and it is. So we can't do anything else to this inequality. The first critical number is 0. The fifth critical number is 2 pi. The period is 2 pi divided by the absolute value of b, which will make this 2 pi. Our increment will be the period 2 pi divided by the 4, which will give us 2 pi over 4, which reduces to what? Pi over 2. And then we're going to find our 5 critical numbers. Remember, this is our first critical number from our inequality. Then we continue to add our increments each time. And when we do that, we're getting 0, pi over 2, pi, 3 pi over 2, and 2 pi. Remember, the first thing, again, we have to do is graph the sine function. So the sine function is not really a part of it, so what I did, I dashed it. And since our a is 1 and it's greater than 0, well, since it's positive, the sine curve is going to have a mountain and then a valley. Okay, so I have my 5 critical numbers. And remember, for a sine function, the first, the third, and the fifth critical numbers are always on the axis. And again, since the a is greater than 0, which is equal to 1, at the second critical number, we're going to go to a max point. At the fourth critical number, we will go to a minimum point. Now, we're using that sine curve. You see right here, on this x-axis, the y is 0. So you see, y equals 0 is undefined. So we're going to have a vertical asymptote at x equals 0, x equals pi, and x equals 2 pi. And that is x equals 2 pi, x equals 2 pi that you have there. And then we're going to put in the 2 pieces of our cosecant function. You can think of this as up on a mountaintop. So it's going to be concave up. See, up on the mountaintop, concave up. And it's right here, you see, at that point right there. And down in the valley, see, concave down. Down in the valley, concave down. Now, when we're looking at this cosecant function, you have to look at each piece separately. Like this is a piece that is concave up. And we're going to have a a minimum at pi over 2, 1. You see concave up. This is the smallest y right here. Think about it. This is the maximum point on the sine curve, but it's the minimum you see on the cosecant because they're what? Reciprocals. And then over here, look at this piece separately. It's concave down. So this is going to be the largest y for this piece. So we're going to have a max at x being 3 pi over 2 and what? The negative 1. And I summed up what I was just saying about the minimum, the maximum, and the vertical asymptotes. The minimum, the max, and the vertical asymptotes from the graph. Now, the next thing we're going to do, we're going to sketch another cosecant function. And this is the cosecant function that we're going to sketch. First thing we'd have to do, we have to graph y equals 2 times sine of 2x. Remember, reciprocal functions. Why? So that we can find where we're going to have the vertical asymptotes. So our 5-step procedure, the first thing we're going to do, now remember this is our A and this is our B. The bx minus c is 2x. So we put that in here. We have to get a single x, one x in the middle. So we have to divide all three sides by 2, or dividing by 2 is the same thing as multiplying by its reciprocal, and we're going to be getting 0 is less than or equal to x. See, I have the 1x by itself here, less than or equal to pi. This is our first critical number, and this is our fifth critical number, and our period is 2 pi divided by the absolute value of b, which ends up being pi. Our increment is the period divided by 4, which is pi over 4. Then, here, remember our first critical number was 0 from the inequality. We then add our increment each time to get our 5 critical numbers, 0, pi over 4, pi over 2, 3 pi over 4, and pi. Then we're going to sketch our sine curve. And remember, since the A is greater than 0, it's going to have a mountain, then a valley. And for the sine curve, also remember that the first critical number, the third critical number, and the fifth critical number are on the axis. The second critical number will go to a maximum point. The fourth critical number will go to a minimum point. But remember, we cannot have division by what? 0? So wherever this sine function is equal to 0, we're going to have our vertical asymptote. So it's going to be at 0, x equals 0, x equals pi over 2, and x equals pi. So once we put in our vertical asymptotes, we're now ready to sketch our cosecant function. And you see the mountaintop, up on the mountain, you see I have that point right there on top of that mountain. Up on the mountain, concave up. Down in the valley, you see down in the valley, so it's going to be what? Concave down. And we have to, again, look at each piece separately. We're going to look at each piece separately. So this is concave up. And this y right here is going to be a minimum. So we're going to have a minimum at pi over 4, comma, what, 2. We're going to have a maximum. So look at this piece separately. This is going to be the largest y right here. So we're going to have a maximum at 3 pi over 4, 2, negative 2 right here. And again, we have our vertical asymptotes at x equals 0, x equals pi over 2, and x equals pi. And here, I have summed this up of what I just said about the minimum, the maximum, and the vertical asymptotes. And remember, when you're viewing this video, you have to stop, rewind, review, stop, rewind, review until you understand what you're doing. And my love goes out to you.